Hey, and welcome back to another episode of VRF Viewpoint. Alright, so today I want to take a minute and talk about error codes. Now, with Mitsubishi VRF, there are a lot of error codes. I went and briefly skimmed through the manual trying to count them. There's got to be close to 100 of them. Now, what's interesting though is I have not seen most of them myself. I don't even know if I've seen half of them. So I wanted to focus on a couple error codes that you're going to see a lot more often than others. So I've got like 5 or 6 of them. And then I've got a bonus one, an error code I find funny every time I see it. So the first error code I wanted to go over, and this one will drive you nuts if you've never run into it, is a 6607. And if you go look at the definition of the error code, it's a no ACK response or something like that. Basically, it's a no acknowledgement. So these units are talking to each other. They're reporting information. Back and forth constantly. They're sending packets through the MNet, their communication protocol. And so if one of these units tries to talk to another unit and that unit does not talk back, it's going to get a little upset. It's going to try a couple times, but after a certain amount of attempts or retries or over a certain period of time, it's going to say, okay, enough, there's a communication issue, and it'll throw 6607. There's actually a bunch of different communication errors, but of all of them, I see the 6607 the most. So, things that will cause a 6607. A broken communication wire, a loose communication wire, a communication wire that is too long, a communication wire that is run in the wrong gauge of wire, or that has a shield or doesn't have a shield, what's called out. Interference being put into the lines, sometimes you'll find a big spool of that stuff just up on a unit. They thought they'd need some extra length and they left it there. All of those things can cause those signals back and forth to get lost or to not be clear, and can cause these communication errors. Most often though, the thing I see the most is the unit gets turned off. The unit gets turned off, another unit's trying to talk to it, and it says, hey, the unit disappeared, where'd it go? And then it'll throw the 6607. And basically it says that unit is not talking back to me. And so some of the units, if you shut them off, you'll get an error code on other parts of the system. Like if I turn an indoor unit off, the rest of the system will continue to operate. And it's important I point this out because some brands of VRF, this is not true. If you shut one unit off, the whole system turns off. But for Mitsubishi, if I shut one off, the branch controller is going to say, hey, I can't talk to that unit. I'm not going to keep sending refrigerant there, and maybe it was in cooling mode, but outdoor unit can't talk to it. It's going to stop counting it, as needing cooling. And so they'll throw the error code and they'll change their behavior. But if you see a 6607, know you're automatically dealing with something communication related. And more often than not, turn everything back on and it'll work. We actually had an issue similar to this where someone had turned the branch controller off, and everything in the system freaked out and nothing would work, and started hunting around and found the issue. So that's the first one. Second one, and this one's a little interesting, and I got a couple interesting stories with this, but would be a 4250. Probably a good time. So with these error codes, should have mentioned this earlier, you've got 2 varieties. You've got a hard code, which when it throws the hard code, it will shut the system down. Like, this is a serious code. It's enough of a problem that it's going to shut at least a portion of the system down. And then you have what we would call preliminary code. And the preliminary code is, the system's like, hey, I got your back, I'm watching all this stuff. Something happened. I had to change my behavior, or I shut off for a minute and retried. But I created an error, timestamp, I got over it, but by the way, this thing happened. And the preliminaries, usually it'll give itself a couple tries. If it sees the same preliminary 2 or 3 times in a certain period of time, it'll progress to the hard code. Anyways, so that's a side note. So with a 4250, what that typically means is the inverter board in one of the outdoor units saw too much amperage. Pretty straightforward, you'd think. So what could this be? Well, sometimes when the inverter board fails, it just blows up and blows the fuses and trips the breaker. Sometimes. Sometimes when the inverter board fails, it can actually detect that the failure is coming. It starts seeing high amperage, things like that, and it will actually trip out. And you'll get the error code even though the board may be failed. You know, you'll get the error code and you have a heads up. There's a problem with the inverter. If you're pulling these through maintenance tool, get the detail code. You might not know what that is, but when you pull up when you scan the system, you look at the addresses and you pull up the error log, it'll tell you a detail code. Write that down when you note the error, because the same error code can mean different things for different detail codes. So, inverter board saw too much amperage. What can this mean? Well, it could mean that any of the loads or any of the wires connecting to those loads coming off the inverter board overamped. So, for example, let's say you had a nick in the wire, the lead's going to the compressor. If it sees that there's a ground there, or if it, you know, catches it before it grounds out and, you know, blows the board up, it can throw a 4250. That's not one I've actually seen yet, but it's a possibility. The inverter board is actually also feeding DC voltage to the fan boards, and so not seen it yet, but I imagine if those were overamping and the error was caught, you'd also probably see a 4250. So typically when you see a 4250 though, it's going to be the compressor, which is the main thing being fed off the inverter board. And so 4250, I'm usually going straight there. A couple interesting things. 4250, a dead compressor, if the inverter catches it before it, you know, starts blowing stuff up, a dead compressor will always be a 4250, but a 4250 will not always be a dead compressor. So for example, we had a system, one of the outdoor units was off for an extended period of time for a different reason. And so we were running one unit and we didn't close any refrigerant isolation valves. Well, it was cold outside and a lot of the refrigerant in the system settled in the unit that was off. When we went to turn it back on, the compressor tried to start in that unit, and after about 45 seconds threw a 4250. And so we power cycled it, tried it again, same thing. And what we came to find out is that the compressor was completely full of refrigerant, like top to bottom. And so we actually had to get some heat on the compressor, get the refrigerant driven out of the compressor. We started up, took off, ran, no problems. And so yeah, if you're trying to start it full of oil or start it full of refrigerant, it was crazy because the compressor was actually shaking back and forth trying to start. But it detected that it was pulling way more amps than it should be, and it shut things down before anything else could get damaged. I've also seen a similar situation with seized compressors, where they just kind of, you can hear them trying, but you know, there was one that sounded like a bag of hammers, and the thing was just shaking around. You could just hear all the mechanics inside were broken up, and it tried for 2 or 3 seconds and then shut off and threw the 4250. And I won't get into how this came about, but if you put the wrong voltage compressor in, like if you have a 3-phase 480 unit and you put a 3-phase 230 volt compressor in there and you try to start it, just so you know, throws a 4250 for very similar reasons. It's just the wrong voltage, it's trying to start, it's not going to work. Don't try that one yourself, just take my word for it. So anytime the compressor is trying to run, it's pulling too many amps, whether it's seized, whether it's grounded, and I've seen my fair share of dead shorts, or whether there's a nick in the wire, or any of those things can cause that error code. But when you see that error code, that's where you're going to want to start. Okay, so, and the preliminary to that's a 4350. Next error code, 1500 and 1600. 1600 is the preliminary, 1500 is the hard code. This is an overcharge error. And so the system doesn't actually have any way to know exactly how much refrigerant's in it. And so all it has left to look at are symptoms. And so if you overcharge the system so much to the point that the refrigerant has nowhere left to go but to flood into the compressor as liquid, you will get overcharged errors. And so there's two sensors that the system's looking at. On an R2 system, these are going to be on an R2, a modern R2 system, so like a K-gen, L-gen, J-gen, I believe, or the N-gen. It's looking at your TH4, which is your discharge line temp, which is just right off the compressor on the discharge line. And then it's also looking at TH15, which is on the shell of the compressor down at the bottom at the oil level. And it's looking at these two, and it's calculating discharge superheat with TH4, and it's calculating suction superheat or crankcase superheat at TH15. And if the superheat in either of these places gets too low, basically it's figuring there's liquid there. Liquid's there, it's flashing, and it's just gobbling up all the heat, and you start to see low superheat. And so it's comparing those to the transducers, the high side and the low side transducers. So what could cause this? Number one cause, too much refrigerant in the system. It may be that the refrigerant amount is correct, but it's settled in that unit. You know, and maybe the compressor wasn't full, but the accumulator was. Compressor takes off, starts sucking liquid, and then you start getting error codes. Best solution is to heat the accumulator, get the refrigerant to boil off, maybe run the other system. Anyways, couple interesting ones with that: if the discharge sensor goes bad, or if the crankcase sensor goes bad, or if the high or low side transducer goes bad, or are reporting incorrect temperatures or pressures, I should say, you can get those errors as well. There was one recently where a tech I know was getting 1500 errors. He, you know, you start investigating what it is. Do I need to go pull the refrigerant out? Like, what do we need to do here? And he went and he found that the TH15 sensor that's on the crankcase was disconnected. It was just hanging, a few inches off the compressor, and so it was reading ambient more than it was reading the compressor. So in the winter, that's quite cold. So it was reading cold temps. It thought it had low superheat, and it was throwing that the overcharge error. So yeah. So when you start seeing these, typically too much refrigerant, but could be a lot of different things. Look at the logs, and if you start seeing weird readings, if you see a crankcase temperature that's not really changing as the compressor is running, you know you may have a problem, or maybe you need to look at your sensors or order some new ones. So interestingly, the next one also ties back into that same TH4 sensor, the discharge line sensor, and those error codes would be at 1202 or an 1102. And so this is kind of the opposite problem, where the compressor is getting too hot. And so 1102 is the hard error code, and 1202 is the preliminary error code. And so what does it do if it gets too hot? And when I say too hot, I mean it's a really high temperature. It's like 240 or 50 degrees. It's quite hot, quite hotter than you'd ever want the compressor to run. And it's got other logic, like if it starts getting even close to that temperature, it starts to slow the compressor down and things. But usually, I've actually not seen the hard error code very often, because it changes its behavior as the compressor temperature starts to get high. But basically, if the compressor is running and it's overheating, or the sensor goes bad, it's going to start throwing these errors. It's going to change its behavior. And so what it's probably going to do is it will slow the compressor down. And it says it's shooting for a target pressure, but if the compressor is overheating, it's going to sacrifice the target pressure to not damage itself. Interestingly, if it runs hot long enough, it actually slips into a mode where it tries to recover liquid from the system. It thinks, well, maybe it's trapped inside in some idle line sets, and it will open valves and change its behavior for a minute to try and pull some of that back. So it's actively trying to move refrigerant around and correct itself. And there are times when that's all it really needed to do, and so you'll get this nuisance trip just every blue moon when just kind of a hiccup. But if you have a system that is low on charge, this is the error code you'll get, because as it's trying to ramp up to, units are behind temperature, it's trying to hit its targets, it's trying to build head pressure in heating mode, or it's trying to cool in cooling mode. As it ramps up, you don't have enough flow through the compressor overheats, so it starts throwing this error code. Same thing if you have restriction, same thing if you have cross piping, if you have plugged strainers, if you have plugged dryer, if you're using the bypass. All of those things could lead you to have that 1202. So most likely, if you're seeing the 1202, you're low on gas. You have a leak somewhere. Find it, correct it. But like I said, with all of these, there's the thing that it usually is, and then there's all the other things it could be, the less likely possibilities. Okay, so the last one I've got here is a 7100 error. And this one will actually go along with the 4250 I talked about earlier. Mitsubishi R2 systems have a nifty little feature built in called emergency operation mode or something like that. And so basically, if you have a twin system, let's say you have two 10-ton units that are twinned together, and let's say the compressor in one fails, the other one can detect that error code, says, hey, my twin is throwing this error code because they're talking, and it says, I'm going to take over as the main. And it'll do this for some period of time. But basically, it will take over and attempt to run the system. It's not going to shut down. Some error codes, it's going to shut everything down, but some of them it'll shift and say, okay, we're going to try to run the one unit by itself. Now, the interesting thing is with it taking over as the main unit, if you have more than 150% of its capacity calling, so if it's a 10-ton and you have 20 tons of units, if more than 15 tons are calling, it will prohibit some of those units, and then the units that are shut off will throw a 7100 error. And 7100 is an overcapacity error. It means that you put too much stuff, you put too many indoor units for the outdoor units that you have. I mean, in theory, you could also have this on startup if you hadn't designed the system well. You put 18 tons on a 12-ton system or something like that, or 19 tons. I guess you'd probably do 18 tons, thinking about it. You're allowed up to 150% before you start getting this error code. And so I recently had one where a system had an electrical fault, blown the breaker. They had couldn't communicate with that unit, so the other one took over. And what the customer saw in the space was the 7100 error. And they're like, it's some capacity error code. They looked it up, they Googled it. It's some capacity error code, something wonky with it. Come to find out, it was doing exactly what it was supposed to be doing. But yeah, and if you are going to be running that kind of a situation, so let's say you're ordering parts and you've got a dead compressor, or you've got a dead circuit board, or whatever, or you're going to be doing a repair on one and you're going to be running the other, selectively choose the ones that you want to shut off to get it back under that 150%, and then you can control what it's running and what it's not, instead of it just shutting off whatever it's going to. So those are some of the most common error codes that I've run across, and ironically, most of them are refrigerant related. But for every component in the system, every sensor, if it detects that sensor's gone bad, it'll throw an error code. I remember one that had been unplugged for some reason, and it had an error code. It thought the sensor was bad, and it threw an error code. It was like 5215 or something. It's like, that sensor's bad, and it wouldn't run because it was a sensor that was important to the operation of the system. I've seen the same thing with a transducer that had gone bad, where it knew the transducer was bad because it wasn't making any sense, and so it still ran, but it ran a little weird. It was more cautious almost, and it threw an error code. Hey, this sensor, we know it's bad. Okay, the bonus error code that just makes me laugh every time I see it. So you have the fans outside, very complicated fans. They're variable speed. I've changed one ever. I don't even know what caused it to fail. They're not high wear and tear, so they're like 6 or 8 pole DC motors. They're really nifty. They have fan boards that run them. But basically, they know the RPM of the motor, like the motor's reporting it back or it's calculating it somehow. And it gets a little uppity if what it thinks the RPM of the motor should be and what it is are two different things. And so I remember going through, I was doing a maintenance and I was pulling error logs, just looking at units. And I started noticing this error popping up on every single one. So I wrote it down, and then I was on the next one. I wrote it down, and I was looking at the timestamps, and they all threw the error within like a couple hours of each other. And so I started digging into this error code. I'm like, what is this? Like, what happened? Was it a power bump or something? And basically, it was like a position detection error, and it's like the fan was not spinning at the speed that it was supposed to be spinning at. And it freaked the system out. And so I looked at the day, and the weather indicated that they had high gusts of wind, and the wind was literally just spinning the fans, and the systems did not like it. They're like, the fan is not supposed to be spinning. You can get similar errors to it. For over voltage, you spin a motor, you'll create voltage, and it's not wanting to see voltage there. It's like, hey, there's over voltage. Anyways, there's a whole family of error codes for those fans. The ones I was looking at was a 5305 or a 5306, and that's detail code 136, or a 4225, 4226, detail code 109. So anyways, lots of fun error codes. And a little pro tip: if you're looking for an error code, if you have a printed manual for these big 300-400 page manuals, don't use your printed manual. Go to my link drive, download the manual you're looking at to your phone, get the PDF, open it up, and then search for the error code. And you might get 6 or 7 hits and go look through them. There's a section in the book where it tells you the error codes and the preliminary codes and which units can throw it. And then there's another area later on in the book that tells you what to be looking at. And that's where you would look up your detail code. And that's where you would look up, okay, what do you check? What procedure should I be looking at? And it starts to give you direction on where to look. So you'll be flipping around in the book for hours. Get the PDF, search, find the code, and then start digging into it and chugging away. Anyways, I appreciate the error codes that Mitsubishi has. They really cut down on the troubleshooting time. And once you know what the error code is and you know what you're looking at, it's pretty quick to dig in and find a solution. Hopefully the parts are somewhere close by, but no, it's been fun to learn. So if this is content you enjoyed, like the video, share it with friends, share it with somebody that's still flipping through their paper manual looking for error codes. And if there's content you'd like to see or any feedback you've got, leave it in the comments below. So until next time, guys, my name is John, and this is VRF Viewpoint.